Good evening, everyone. My name's Stuart. Thank you for inviting me here. It's good to be back. I spoke here 4 years ago, so it's been a while. And I'm here to talk about JSON Schema. I'm here to do an introduction to JSON Schema and show you how I use it for validating APIs. Chris has already said a lot about me from my bio. I've got about 25 years of industry experience. I've seen a lot, but not everything by any means. The company is Ganbaro Digital. If you want tech stuff, please follow the company. You can follow me on Twitter, but those who already do, be warned, I'm passionate about my causes, I'm passionate about my hobbies, and I tweet a lot about both, probably more than tech these days. So if you only want tech, follow the company rather than me, would be my recommendation. Okay, so if I heard correctly while we're going around the room, there's quite a few JavaScript developers in the room here. So how many of you have actually got hands-on experience with JSON Schema already? Someone must have. No? Okay. I'll work with that. We'll find. So, okay. That's a surprise. It's not a new technology. It's been around for many, many years. I really would have thought someone would have been using it other than me. So why am I using it? What's my interest in it? When I started the company, I started off doing QA work. I would go into projects and into firms and do quality audits for them. I'd audit their source code, do reviews, set up quality standards, and do deep audits and produce metrics on the code as a result for people. And one of the things I noticed is people tend to write API validation code. When you get input into an API, tend to write it by hand. And I've seen a lot of that style of code. And I've been doing network code since the 80s. Shows how old I am, I'm sorry. And everyone does it handwritten. But the problem is with that, there's a lot of problems with it. And I don't know if any of these resonate with you, but when you're validating your APIs, those of you who work in larger teams, do you see duplication? Yes, there's some nods over there. Yep, and from over there as well. And how good is your coverage? How good are you at covering 100% of the data that's coming in before you use it in your business logic, before it reaches that business logic layer? So having actually had to crunch numbers and produce statistics for projects, I can tell you that certainly once you get past about 4 or 5 people, no one does it 100%. And it's not a competence thing. We're human beings. We are rubbish at doing things 100% of the time. It's just not us. It's not what we're for. That's what automation's for. So I moved from auditing projects to rescuing projects and building new projects. And I didn't want to repeat the mistakes I'd been writing up for other people on previous gigs. So I was looking for a better way to do it. And that's how I got interested in JSON Schema. I'd been aware of it from previous jobs, but I'd never used it myself. So it gave me an opportunity to sit down and have a look and see, can it do the input validation that we want? And that's what we're going to explore with this. Now, one thing I want to make out is I've only been using JSON Schema for just over 18 months. Now, I don't think that's a long period of time, to be honest. So I'm not up here to tell you this is how JSON Schema works. I'm an expert in it. That's not what I'm here to do. I'm simply going to share with you what I've done to get it working in both PHP and JavaScript and be able to share schemas across the 2 languages, which for me is a vital thing. I'm here to learn from you as well. You haven't used JSON Schema, but I'm sure there's something you can teach me as well while we go through these slides. So if any of you have ever, all my talks are videoed and we put them up online, so if any of you have ever seen those, you'll see they turn into 2-way conversations. And I'm going to do my best to do that with this talk as well tonight. So please don't be shy. Now, before we dive into JSON Schema itself, we've got a diverse audience. I want to make sure we've all got a common understanding of what an API, how it works, and how API requests work. So we've got that common understanding to then show how JSON Schema fits into all of that. And we'll do it very quickly. So if we take a HTTP API request, the very first thing in that request is the HTTP verb. In your frameworks, you might see this referred to as the method. It's quite a common term used in PHP frameworks for sure. And that's things like get, post and put and patch and things like that. I'm sure you've all seen that. Then you've got the query path, which is used for routing in framework-driven applications. If you use, for example, Express in JavaScript, or something Symfony you mentioned, or Laravel, they've all got routers that load your action or your controller based on matching the route. For my examples, you can always tell what client I was working on at the time I wrote the slides. One of my clients does football memorabilia, that's what they sell. And I provide a data engine for part of their websites. But that's a query path anyway. On the end of query paths are optional query parameters, and they're originally intended to filter the results that are sent back to you. That's the original intention with them. So here's a query path with some query parameters on. And hopefully the orange shows up in this bright light. Everything after the question mark are query parameters. And they're primarily used on GET requests. You can use them on others, there's nothing stopping you, but GET is where they're commonly used. Then you've got all the HTTP headers, which our frameworks collectively bundle up, and they call that metadata in one form or another. Or you might see them as attributes, depending on which framework you're using. And for APIs dealing with JSON, obviously the best example is the content type, which is normally set to application JSON. And then finally in a HTTP request, you've got the request body itself, the payload. And it's that we're interested in. I'm sorry, am I blocking your screen? All right, sorry. It's the payload we're interested in validating with JSON Schema. I'm ignoring all the validation of all the other parts that have come through beforehand for tonight's talk. I'm just focusing on this payload. Now, some of you who are familiar with HTTP may think this goes without saying, but I have seen projects where they try and send request bodies on verbs that don't support them. For example, get and head. Standards say it doesn't work, but it can work on some systems, but you still shouldn't do it. What we're interested in are these HTTP verbs, post, put, and patch in particular. And the reason we're interested in those verbs and the request bodies they've got is because we're being sent data to change what we store in our systems, change the state of our systems, change what we're storing in our database. That's the whole point of sending us data. They normally change permanent state in one form or another, which means these API payloads are a form as user input. They're no different to someone typing data into a form. We're just reaching us in a different format. It's still user input. It's still for security purposes. You can't touch it until you know it's safe to use. Otherwise, you've created the beginnings of a security hole. So how do we process that in our frameworks? And JavaScript and PHP frameworks broadly work the same way. At the core, you've got some sort of action. Once the request has been routed, some action is loaded and it deals with that specific request. Now in the PHP world, we have this mantra, filter input, escape output. Have any of you heard that one? Chris has? And the idea is to make sure that the data is safe before it reaches the action. So the action itself isn't having to redo the validation over and over and over, because the validation is expensive. If you're validating everything in every single method in your app, you can easily take up 20, 30% of your total processing time just on validation. It's something to be careful of. And traditionally, these, in an MVC type thing, this is roughly where the responsibilities are divvied up for this, roughly. But JSON Schema, how could it help us with that? What do you think? What would you, bear in mind you haven't used it, but I'm going to ask anyway. Where do you think JSON Schema might be able to help with this?
I'm guessing it starts at the beginning like a WSDL.
Okay, like a WSDL. Okay.
Could it start even before you send the request?
Could it start before?
I.e. on the front end.
Start on the front end? I have a slide for that, we'll come back to that one.
You might want to do it twice.
You might want to do it twice, yes. Yes, that's a good point, we're going to come back to that. Anybody else?
I agree with Kev. Kev's nailed it.
Okay.
In your dev tools, I suppose.
In your dev tools? I haven't come across any dev tools that support JSON Schema, but I don't use a lot of dev tools, to be honest. I'm a little, I was going to say old school, but that sounds pretentious. I did decades of development before decent IDEs came along, so I don't feel the need for them, is what I mean with that. But where JSON Schema can help is we can extend this pipeline of processing. Before we filter the input, we can make sure the input's in the right shape. We can make sure that it's got the right fields in the right places with the right data types. So we can validate the format of the incoming data. And also, I've got a very strong QA background and I talk a lot about robustness and things. It's nice to actually reuse these schemas on our responses that we send out because they're also JSON. So we can also validate those and make sure we're not sending crap data out to some poor unsuspecting front end, which then has to cope with something it's not expecting, which isn't fair on anybody, okay? It's much better for us to catch it here and say, oh, look, our server's broken. Much better to catch it there. So we can use it there as well. And JSON Schema can actually help us with some of the input filtering as well. We can actually delegate quite a bit of that to JSON Schema, which means we can replace a lot of handwritten code and we can do things that currently we generally don't do at all with handwritten code, which to me is why I'm very interested in it. So what I'm going to show you for the rest of this talk is how you can use JSON Schema to validate input on a JSON API, that you can use JSON Schema to validate input if you're sending JSON out of your API in responses. And as you said yourself, the client itself can reuse these same schemas. That's one of the reasons I'm interested in schemas that can be shared between JavaScript implementations and PHP implementations. Again, for robustness, you want to catch problems as soon as possible. If you're developing an API client, you want to catch bad data before you send it up to the server. It helps your development process because it allows you to iterate faster. And again, if you're receiving data from somewhere, you want to check it yourself. You can't trust, just because it's come from a server, it's still user input. It's just input from a different direction, that's all. So you can validate it there as well to improve your robustness and your quality. Sound interesting? Yeah. Sound better than handwritten code? That's hopefully what I'm going to convince you with. So what I'm going to do now is I'm going to walk you through JSON Schema and I'm going to show you a little bit of what it looks like. And this really is JSON Schema 101. I'm not going to be doing advanced features. I'm not going to be attempting to cover the complete spec by any means. Now, the first thing to note is JSON schemas are written in JSON. As part of the research for this, I went on, I think it's a Google group where the JSON Schema spec discussions happen. And you have to wade past all the people who go on there to say, it's written in JSON, therefore I'm not using it. The fact it's written in JSON is a barrier to entry for them. So if you don't like JSON and you don't like writing stuff in JSON, I'm sorry, JSON Schema isn't for you. There's no way around that. Okay, so what does the schema look like? First of all, I apologize for the size of it, but we've got quite a bit to fit on the screen. Can you all read that? The slides will be up online after the talk as well. The first line of our schema is a keyword called $schema. And what it does is it tells our validator package that we're using which version of the JSON Schema spec we want it to use. Okay? There's quite a few versions, and I'm going to talk more about that before the end of the talk. The next line is an ID. It tells the validator what to call our schema. The validators don't use our file names, they use these ID strings. And that allows one JSON schema to pull in another one at a later date, so you can start to reuse those and create a dictionary of reusable JSON schema, which is very handy. Now, I want to point out here something about this ID, because it looks like a URL, but it's not a URL, it's a URI. And the big difference is the validators don't expect that to point to a real file anywhere. It's just an ID. The validator should not be even attempting to load from that URL at any moment in time. It's just an ID to tell these documents apart. That's all it is.
Is that equivalent to a namespace?
It's used as a namespace, yes. Very much so.
Why does it have a protocol in front?
Why does it have a protocol on the front? Just to fit with the scheme they've chosen. because they've said it's going to be a URI or an IRI in the latest draft as well, to support Unicode characters as well. But it is just treated just as a namespace. Now at this point, the schema documents can go in one of two directions. We're going to look at a simple schema first, and then we're going to come back to a compound schema later on. Now a simple schema describes one data structure. That's all it does. And every data structure has a type. And it's JSON schema for JSON documents, so it uses JavaScript types, and it supports 6 JavaScript types. Yes, there's 7 on there, but the JavaScript developers in the room know why it's actually only 6, because integer doesn't exist in JavaScript. So what they've done in JSON schema is they've set if integer is an alias for a number, but it's not allowed to have a fractional component. But underneath, it's actually a number, and or anything that passes as a number in terms of what you can do with it in a schema works with an integer as well. Okay, so that's it. But yeah, for PHP programmers, that's a bit, or C programmers, that's a bit different. I'm not saying it's better, I'm not saying it's worse, it's just different. You get used to it. So we put type in there, say type string, type object, or type array. And at that point, that's a complete schema in its own right. You can stop right there and use that to validate data at that point. You can leave it as thin as that if you want. But obviously, we want to be more descriptive than that. And that's where constraints come in. And every one of these 6 types and the alias integer has its own unique set of constraints. I'm not going to go through them all by any means tonight. What I'm going to do is send you to read the spec. Assuming I've not used a dodgy QR code generator, that should take you directly to that URL where you will find all the different validator keywords for all the different data types documented. And once you understand JSON schema, the spec actually is quite helpful. It's a spec, so it's not nice to learn from. But once you know what you're looking for, the spec's actually really helpful. And I have it open in a tab most days when I'm working on JSON schemas.
It works.
Sorry?
It works.
Awesome. I think you're the first person to test one of these live during one of my talks. Don't worry, it comes up again. Now, in the spec, it calls them validation keywords. I'm a great believer, though, that the language we use for something affects how we think about it, how we approach it, and how we use it. And I think validation keywords gives the wrong impression. And that's why I use the word constraints instead. Because the way JSON schema accepts and rejects data is a little different to what you might expect. See, what happens with JSON schema is all data is accepted unless you reject it. That's why I call them constraints, because you're writing rules to say how to reject data. You're not actually writing rules to say how to accept data. So you've got to have 2 criteria met in order to reject incoming data. First of all, you've actually got to write some strict criteria. You've got to write these constraints. Otherwise, there's nothing to reject the data. And then you've got to receive data that doesn't pass these constraints, that falls foul of it, trips over it. Otherwise, you're going to get data through. And it's not a point that I think is made very well in the existing tutorials and existing documentation on JSON schema. It's kind of, I'm sure it's in there, but it's kind of glossed over, and it's one of these things that really got to repeat to people over and over when writing schema. Because one of the hard parts of when you first get started with it is thinking, why has this data got through to my code? And this is the reason why. Data is automatically accepted unless there's a constraint to reject it. Okay? So I'm going to do a worked example to show you how these constraints work in practice. And I'm building an ID system for someone at the minute, so I've mocked up a user record of some kind. So as we've said before, first line of our schema tells us what version of JSON schema we want the validator to support. And the second line is our ID for this. Oh, sorry, I've got ahead of myself. There are 7 drafts at the moment of JSON schema. as none of you have used JSON Schema before, please use the latest draft. Use draft 7. If you ever use a system where the latest draft isn't supported, or there's already schema written for an older draft, use that older draft. It's better than having no validation at all. Okay? I haven't tried mixing schemas written for different drafts inside the same validator at the same time. I don't know what will happen. I'm not brave enough to find out either. Okay? If any of you try it, do let me know. I'd be very interested. Right, so now back on track. Second line, the ID. And there's a few things I want to point out about the ID. As you rightly said, it's a namespace. So the first part is a domain. Now there's nothing stopping me using PHP Dorset there if I wanted. There's absolutely nothing stopping me. It's an honor system. There is no way for the validator to know what you can and can't use there. But it's a dick move to use someone else's bloody domain. Use your own property, okay? I'm sorry I've had to put this in, but there are people out there who you have to sit down and explain this to. I've worked with people like this. I'm really sorry. At one point, they were just making random stuff up as well. They didn't. I don't know. It was just, I don't understand their mindset, so I can't explain why they were doing it at all. But use your own, and then that's great for everybody. I mentioned that these aren't files on disk. You can put them all in the root of the domain if you want, because you're not cluttering up a real folder anywhere. Because it's a namespace, in reality, what I do is I tend to split them up. PHP developers, hopefully you're using PSR auto-loading of some kind. So you should be using vendor, a package or project kind of thing. Same idea with this, works really well. It's a really good scheme. JavaScript developers, you don't really respect namespaces. NPM's probably single biggest design flaw, I would argue. So grab a PHP developer and ask them to explain it to you if you're not familiar with it. And if they say they don't use it either, then both of you go look it up, okay? But you're absolutely right, it is a namespace. And the whole point of not shoving everything in the root is you don't know what's coming in the future. And it's nice to leave space for that future to arrive. So you can then reuse existing stuff without it clashing if you want to. So that's the whole point of namespaces. And of course, we've got the thing on the end to say what it is. It's like naming variables. You're going to come back to this at some point, or someone else is, who may have your address and be a psycho. The old meme. So don't assume you'll remember what it is. Be descriptive. You've only got to type it once, so type it out, please. From there, designing the rest of the schema, I follow a very simple workflow. I literally start at the outer edge of the JSON document that I'm writing a validator for, a schema for, sorry, and I just work my way inwards. So if we take our record, the absolute outer edge is the fact that this is an object, it's not an array, or any of the other things that sometimes JSON parsers will accept. So we're just going to say it's a type object. But it's an object with properties, so we want to put some constraints in about those properties. And I'm just going to focus on the first property at the top, which is the user ID. How many of you use Unix-like systems, like Linux or something? Okay, so some of you are fully familiar with user IDs. Okay, excellent. So we can just simply say that it's an integer. Type, UID, there's a field UID, and it's type integer. We can just say that. And if we take our record, and we just focus on that field for the moment, our validator will accept this record with that value there. It will be very happy with it.
Do you need to say it's a positive integer only?
In a moment. In a moment. If it's a string, it will now be rejected because we've now got a constraint that says it must be an integer. So it will now be rejected. So we're starting to throw data away, which is what we want. We're starting to reject data, sorry. But remember what I said before about how constraints work and how rejection works? What did I say about how JSON Schema does that?
You accept it until you've got a constraint into it.
Exactly right. So your point is absolutely there, that our positive integer is accepted, but our negative integer, what do you think is going to be happened? It's going to accept it too. Absolutely right. But we don't want that, because Unix systems don't like negative user IDs, with one exception. -1. So, as you've all got your head around this, we haven't put enough rules in place to reject those negative numbers yet, because we're writing a schema to validate a Unix user ID. The JSON Schema validator doesn't know what we're doing. It doesn't care. It doesn't understand the concept of a Unix user ID. It only understands constraints. So you have to put the constraints in for it to do its job. And there's our QR code again, back to the same place, to go and look up all the different constraints that are available. So if we take our type integer, we can expand that from the information in that spec, and we can put a minimum and a maximum on there. That's 2 to the 16 minus 2 for anyone who's interested. Because that will work on every Unix system I know of. 16-bit, but -1 is reserved, you see. And no, I don't know why it's reserved, but it is. But with those rules in place, our positive number is still accepted, which is what we want. Our negative number is now rejected. Okay? I know it seems noddy, but that's the whole point of these schemas, is it really is this simple. Most data types aren't that complicated if you're starting with a greenfield system. If you're retrofitting schemas to mature systems, systems that may have grown organic, that can be more of a challenge. But I have the luxury and the great privilege not to have to worry about that tonight. So that's we've said that it's the constraints for a Unix user ID. Now, if you've got an API that accepts Unix user IDs at all, chances are it's going to accept them in more than one type of request. They're going to be used in multiple places. So it'd be nice if we could reuse that, wouldn't it? Yep. And so avoid us having to create new ones and avoid all that duplication I mentioned at the start. And that's how we get into compound schemas, which is the second way these documents can go. There's probably an official term for this. I think they just call it a schema, but I'm going to call it a compound schema because it defines multiple data types inside a single file. So I like the word compound for that. And it's very easy to do. If we take our existing structure, where we've got our definition for our UID and the fact that we're working with an object, if you look at the details for that UID, I hope everyone can see that. That is actually a little JSON schema in its own right. One of the really nice things about the design of JSON schema is it reuses the concept of a schema in many different places inside itself. That actually makes it really powerful. Possibly a little too powerful at times, and some implementations trip up over that, but it's something we can harness. That's actually a little nested JSON schema. So we're going to start a new file, and I've put the ID up because I'm changing this. Instead of it just being a user record, which is what it said originally, I'm calling this Unix because it's going to define several Unix ideas. And next, instead of a type, we put an object in there called definitions. And it has to be called definitions. You can't call it anything else. I believe older versions of the spec left that a little vague. But I checked the latest draft, and the latest draft says it must be definitions now, which helps enormously. And then we just take what we had before and we drop it in. And now we have a definition for a UID that we can reuse. And hopefully you can all see this. I just want to point out that this little schema has its own ID keyword in. Remember, we've got one at the top of the file? Well, we've now got one actually inside our little subschema as well. They call them subschemas, these little ones. But you notice it starts with a hash. It's not a full URI in that respect. We're using the idea of a URI fragment because we're inside a larger document. And what happens is that, as you would expect with any piece of HTML, for example, we just stick that, everything just sticks a fragment on the end of the URI at the top of the file. So it now looks like that. That is the full ID for that particular schema if you want to reuse it from somewhere else. I like this a lot because it works with technology we're all used to working with. Now, if you go through JSON Schema tutorials and docs, you will see other ways of doing this. Don't use embedded IDs like this. You'll see some, I think they call it JSON Path, but it's not quite the JSON Path I'm used to using. You'll see, I think there's 3 different ways I've seen so far. This one works in every validator that I use, which is a big bonus for me. And I like the fact it's working in a way that everyone understands. Whenever I've shown a schema to someone, they just see the fragment on the end and they instantly know how it works with the ID at the top. It's not something you have to spend a lot of time going, well, how do I actually reference this? Okay. One other thing I want to point out is our little subschema, obviously because it's because definitions is an object, we have to give it a property name. Definitions isn't an array. It's actually an object. I kind of wish it was an array, so we could drop these fields, but for the moment it's an array. So the spec says nothing at all about what these properties should be called. So I just use the same as in the fragment, and that way I don't trip over myself in large documents whatsoever. I find that works really well. So it's not called UID because the field we're validating is UID. This has got nothing to do with the name of the field in the data that's coming in. It's just that this is a Unix user ID. That's why it's called UID. Okay. So that's our full UID schema in a document where we can now add other JSON schemas to. And that's a compound schema. That's all there is to it. What do you think so far? That looks really easy to reuse, doesn't it? Yep. It looks a lot easier to use than handwritten code. And a lot easier to maintain as well, I hope. Now, to get at this stuff, we need another keyword called $f to tell our JSON's validator we want to reuse as part of our schema. I'll show you how that works. Here's what we've just built. Here's our user record. I'm just going to highlight some parts. So what we've done is we've still got our user record. It's an object and it's got our properties. But for the UID field, instead of writing out the schema again, we've used $f to tell it to find the schema with the ID #UID. And because it's in the same document, that fragment auto-resolves to the UID that we've already defined 5 minutes ago. That's how it works. If you want to refer to something in a different document, you just put the full ID in.
Can you refer to it if it appears after?
Yes, you can.
So say your validator, would you just give it very different documents if you had like a few of them?
Absolutely do. I've got a slide for that at the end. But that is an excellent point. It's an excellent point. So what you're asking there is how, because the validator doesn't go and load them, how does it know where to get them from? And I'll show you that towards the end of the talk. That's a very good point. So that's what I'm going to show you for now about JSON Schema itself, about how it looks and how it works. I've got some more examples towards the end of the talk, but I'm going to move on in a moment and show you how we consume it, and then I'm going to share some things I've found from the last 18 months that I wish I'd known when I'd started. Does anyone have any more questions about the JSON Schema itself before I move on to that?
Are there any standard definitions anywhere? Can you sort of...
Not what I've seen.
So there's no sort of documents that you can refer to that have got things like user IDs that will be fairly standard across?
Not that I've seen.
Okay.
It would be nice if there were. I'll be honest and say I haven't looked very hard for them. So there may be some out there that I'm not aware of. But as we've demonstrated in the room, JSON Schema isn't widely used at the minute, despite the fact it's at least 6 years old maybe 7 years old, but it's at least 6 years old. So maybe someone has. Maybe there's an opportunity for someone to start that and start making up that dictionary.
Because typically you'd have one for email validation, wouldn't you? That's a common example of something that appears simple, but it's actually
Incredibly complicated.
and you get your preg replaced and all that goes.
That would be something that would be handy to put in place. If you feel after this talk you're going to go away and start using this, have a look for a common dictionary, some existing ones. Let us all know. Okay? Feedback to us all. And make sure you include me, because I'm not a member of the PHP Dorset meetup group, or you use Eventbrite, don't you?
We use Meetup, Eventbrite, and Slack.
Right. I won't see the message unless you copy me in explicitly.
No, but if a discussion starts up on our Slack about JSON Schema, we'll pass on to you.
Please do.
What's going on with that?
That'd be awesome.
Who's maintaining the drafts?
I don't know.
Okay.
I don't know if it's company sponsored or if it's just a group of individuals. I really don't know. I only go to the drafts when I want to look up how something works. I don't have time to sit down. I don't read PHP internals. And PHP is a language I'm very passionate about. So there's no way I'm going to have time to follow the equivalent of PHP internals for something that, to me, is just a part of the toolkit. But also, as I'll talk later on, I'll talk about why it's not final, why the spec's not finalised yet and where it's going. And that will probably help me put across why also I'm not that bothered about tracking who they are and what they're doing as well. Okay? Any more questions so far? What do you think to this? Does this look really appealing?
It's handy.
Yes.
Yeah.
I'm trying to figure out how you would do email.
I think there's a regular expression pattern you can apply.
Can you apply regular expression pattern?
Yes, you can.
Yes,
you can. In fact, that's about all you can do to strings if memory serves.
Essentially, the concept of bringing a standard to this, as you say, otherwise you're just relying on unwieldy code that someone wrote, especially for legacy projects, to bring up some of our older projects in line with each other, just where there's inconsistencies. This would, we write a definition for one and then try and apply it to another fork with the same project, we'd see where it's gone wrong.
Especially on our front ends.
Yeah.
The other thing with this is JSON Schema, its accept-reject mechanism is very deliberate. It's a bit like the same approach Microsoft took with TypeScript. You can use as little or much of it as suits you, and you can gradually increase it. So instead of, if you're introducing it to an existing project, instead of going totally flat out for JSON Schema, you can just say, right, we're going to validate part of it here, and gradually replace the handwritten validators rather than have to rip it all out in a big bang approach. So it's an approach that can really work.
Does anyone here use TypeScript?
I use TypeScript a lot, and I just googled it a minute ago because I was interested, and there are converters that will go from this to TypeScript interfaces, so that should be quite nice.
Okay. Awesome.
Please. Being acceptable and less rejected, is there a way of setting a requirement so that the field needs to be at least present in the payload?
Yes, there is.
Is that in the later slide?
No, it isn't. That's in the QR code. Follow the QR code and you'll see all the different rules. There is a lot more to JSON Schema, just the spec itself we could talk about. But what I want to do is move on and show you very quickly how to get up and running with it. And then I want to take about 10-15 minutes to go through some of the bumps and bruises I've had during the first 18 months to hopefully save you some pain if this interests you, okay?